So today we started Unit 3, solving 2x2 systems of equations. So there's 3 ways to solve systems. Today we're focusing on graphing. Okay, so you can pause the video, write this down. A system of linear equations is 2 or more linear equations, so we're just going to graph 2 lines and then see where they intersect. So our solution of our system is an ordered pair that makes all of our equations true. So it's going to be easy to tell on the graph what my solution is because we're plotting points. So our solution is just going to be an ordered pair. So there are 3 possible solutions. Number 1 is we can have 2 lines that intersect at one point, okay, and that point is our solution. Okay, so it's our x comma y coordinate, our one solution. Our x comma y coordinate where those 2 lines intersect. Okay, number 2 is we can have parallel lines that are never going to cross. And if we have parallel lines, we have no solution. They're never going to touch, they're never going to cross, so it's no solution. And lastly, we can have a line graphing one line, and then if we graph our second line and it is the same line, we'll have infinitely many solutions. Okay, so if the lines overlap, it's the same line forever, you have infinitely many solutions. Okay, so this is what we did on Monday. This is just a review on how to graph a line. So you guys can pause it and write down the steps. I just want you to know that B is your y-intercept. So that's the number on the outside here when we have it in mx plus b form, and then m is your slope, which is rise over run. Okay, so we start at our y-intercept and we rise whatever our rise number is and run whatever our run number is for our slope to plot more points and draw a line. Then we repeat that for a second line, and where the lines intersect is going to be our solution for our system. Okay, so for example 1, solve by graphing. We have a line, we have 2 lines in y equals mx plus b form. Okay, so for this first line here, we have a y-intercept at 0, 2. That's our B. So we go ahead and plot that. We also have a slope of 1, which is technically 1 over 1. So we're going to go up 1 and to the right 1, up 1 to the right 1, up 1 to the right 1, down 1 to the left 1. Plot as many points as you need in order to be able to graph a decent line. Okay, so that's our first line in our system. Our second line has a y-intercept at -2. So we come down to -2 and plot that. And we have a slope of 3, which is technically 3 over 1 for our rise over run. So we're going to rise 3, go over 1, rise 3, go over 1, rise 3, go over 1. And that's our second line. Where our graphs intersect at that point is our solution. So our solution is the point 2, 4. Okay, if we were to plug our solution, 4. Oh my goodness, 2, 4. Okay, if we were to plug our solution in for y and x, so we would have 4 equals 2 plus 2 into either of the lines, that should be true. Okay, so that solution is true. Let me focus this, there we go. So this statement is true, so that is our solution. Okay, if we have if we have our equations that are not written in y equals mx plus b form, we can go ahead and do intercept form. Okay, so intercept form is going to be where we just solve for our x and y intercepts and plot those. So if we plug 0 in for x, then we technically just cover this up and write what's left over. So we'll have y equals 3. So my y-intercept, we just solved for my y-intercept, is 0, 3. So we go ahead and plot that. If I plug 0 in for y and cover y up, I write what's left over. So I have x equals 3 left over. So that's my x-intercept for my first line. Okay, so I come over and I plot that point and I just connect my two intercepts. For this method, you only need to plot your two intercepts to be able to graph. Okay, and then I do the same thing for my second line. So if I plug 0 in for x for my second line, I go ahead and cover that up because anything times 0 is 0. And I write down what's left over, so I get y equals -6. So my y-intercept is 0, -6. Okay, and then I do the same thing, plug 0 in for y, cover it up, and write what's left over. So what's left over is -2x equal to -6. And then we need to solve for x, so we divide by -2 to get rid of that. And we're left with x equals +3. So my x-intercept is +3, 0. Once again, just connect those points, and my solution is where those two lines cross. Okay, so my solution is at 3, 0. Okay, I'm going to go through this one a little quicker. If we plug in 0 for x, cover it up and write what's left over. So 3y equal to 9 is left over, divide by 3, and we get y equals 3. So my y-intercept is 0, 3. If I plug 0 in for y, cover it up, write what's left over, I have -2x equals 9. Dividing by -2, I get x equals -4.5, which is my x-intercept. So that's going to be over here. Go ahead and connect those intercepts. Okay, if I plug 0 in for y for my second line, so this is line 1. Okay, if I plug 0 in for y for my second line, cover it up, I'm left with -4x equals -12. Solve for x, I get x equals +3. So that is my x-intercept for my second line. Okay, if I plug 0 in for x, I cover it up, I get 6y equals -12. Solve for y, I get y equals -2. Okay, so my y-intercept is 0, -2. Go ahead and connect those points. This is my second line. Okay, and these lines are parallel, so we have no solution. If you see right away that this is already in y equals mx plus b form, then you can use that method for this first line, okay? And you can use the intercept method for the second line. So for this line, my y-intercept is at 1. Okay, so I can go ahead and plot that. And my slope is 1 over 2. So I'm going to rise 1 and go over 2. Rise 1, go over 2. Go down 1 and to the left 2. Down 1 to the left 2. And I just connect those points. Okay, so that's my first line. For my second line, it's not in y-intercept form. If you want to put it in y-intercept form, that's totally fine, okay? Or you can just do the same thing. So plug in 0 for y, cover it up. I'm left with negative x equal to 2, but I want positive x, so we can multiply everything by negative 1 to get positive x equals negative 2. That is my x-intercept. Okay? Then I can plug 0 in for x, so cover it up. I'm left with 2y equals 2. Solve for y, and I'm left with y equals 1. So my y-intercept is at 0, 1. Okay, so the same points are going to mean the same line, which means we have infinitely many solutions. Infinity. Okay, the last thing is with word problems, just to be able to set it up. Trent Scooters, Sam Scooters charges a $20 fee plus $5 an hour. Rosie Scooters charge $10 plus $10 an hour. Okay, so whoever's it is going to go together. We're always going to have y equals, okay? This $20 fee is a one-time fee. Okay, so it's not changing over time, so it's going to be added to the end. This $5 per hour, if x represents hours, okay, that's changing over time. So we'll have 5x plus 20. For our second equation, they're both 10, right? But this $10 fee is a $1 fee. That's what's being added on to the end. And this $10 per hour is changing over time. Okay, so per hour, per x, we have $10. So here's our system, and we would graph it the same way.